Finding an exponential model given two data points. So in our previous examples, we were always given the growth rate. So we were always told that the population was growing by a certain amount, and then we were asked to make the model. But what if we were just given two data points and we weren't given the growth rate? How would we approach the problem? So this is in general what we'll do. If one of the data points is of the form 0, a, then we'll use a as an initial value. And then using a in the second point, we'll substitute to solve for our growth rate, b. And then once we have our values for a and b, we can write our exponential model and use it to answer questions. So here's an example. In 2006, 80 deer were introduced to a wildlife refuge. By 2012, the population had grown to 180 deer, and the population was growing exponentially. Write a function n of t that models the growth of the deer population, where t is the number of years after 2006. So, in general, our exponential function would look like n of t is equal to a b to the t, where a is your initial amount and b is your growth rate. So what we'll do is we'll use this starting point of 80 deer as a, our initial amount. And so what we'll do is we'll use that and our second point. So our second point is this information. By 2012, the population, the population had grown to 180 deer. So notice that 2012 would have been from 2006, 6 years later. And so what we're going to do is we're going to plug in values for n of t, a, and t, enabling us to solve for b. So our second data point was 180 deer equals our initial amount was 80 deer. We don't know b, that's what we're trying to solve for, but that growth took place over a 6-year period. And so now we have an equation that will allow us to solve for b. We'll begin by dividing both sides of the equation by 80. That tells us that 180 divided by 80 is equal to b to the 6th. And to solve for b, we would take the 6th root of each side, or in other words, raise both sides of this equation to the 1/6 power, which you can do on your calculator. So let's give that a try. 180 divided by 80 raised to the 1/6 power gives us a growth rate of 1.145. And now we can use that to write our function. So our function would be n of t is equal to our initial amount 80 times b, 1.145, to the t power. Let's do another example just like that one. A wolf population is growing exponentially. In 2011, 129 wolves were counted in a certain area, and by 2013, the wolf population had grown to 180. Write an exponential function, n of t, that models the growth of the wolf population t years after 2013. So again, we'll start by reminding ourselves that the exponential model would look like n of t is equal to a b to the t. And in this problem, we're not given a value for b. So we'll be plugging in values for n of t, a, and t that will enable us to solve for b, our growth rate. So this is our starting point, 129, so that's our value for a. And our second piece of information was that by 2013, the wolf population had grown to 180, and notice that 2013 was 2 years later, so t is equal to 2. So let's go ahead and plug those numbers into our function. N of t, 180, is equal to our initial amount, 129. B is what we're solving for, and that growth took place over a 2-year period. So just like before, we're going to start by dividing both sides by 129. So we have 180 divided by 129 is equal to b squared. And to solve that, we would simply take the square root of each side, or another way of saying that is we would raise both sides to the 1/2 power. So if we do that, 180 divided by 129, and if we then take the square root of that, or raise both sides to the 1/2 power, we get a growth rate of 1.181. And so our function would look like this. N of t is equal to our initial amount, 129, times 1.181 raised to the t power. Predict the wolf population in this area in the year 2021. So the year 2021, if t is being measured after 2011, 2021 would be a t value of 10. And so to answer that question, we simply have to take our calculators and compute 129 times 1.181 raised to the 10th power. So 129 times 1.181 raised to the 10th power would be equal to 680. Actually 681. I just want to double check that so that it's correct in your notes. Yep, that's what we would get. All right, I'm going to have you try one. I'll get you started because it's the same process, just a different context. So we've been doing some wildlife examples. Let's do a real estate example. This problem is actually a model for our first house. So when we first moved to this area after renting for several years, we were able to buy a house in 1985. In 1985, a house was valued for $145,000. We sold it in 1992 for about $289,000, and the growth of real estate at that time was exponential. So what was the growth rate, assuming the growth was exponential? And if the rate continued, what was the value of that same house in the year 2020? So again, it's the same process. I'll just call it H of t for house price is equal to a b to the t, and a is going to be our initial value. So our starting point was when we first bought the house for $145,000, and time starts then in the year 1985. So we're going to fill in a value for h, we're going to fill in a value for a, we're going to fill in a value for t that will enable us to solve for b. So in 1992, we kept that house for 7 years, so t would be equal to 7. All right, so let's go ahead and plug those values in. I'll get you started, and then I'm going to have you finish it off. So the value of the house, and let's instead of carrying all the zeros, let's just say that our value is, our units are going to be in $1,000. So 289 is equal to 145, b to the 7th. All right. So why don't you go ahead and solve that for b, and then once you have that, see if you can answer the second part of the question. What is the value of the house in the year 2020? All right, let's go ahead and check your solutions to the last two problems. We're going to divide both sides by 145. So that tells us that 289 divided by 145 is equal to b to the 7th. And so what we'll do to each side is raise it to the 1/7 power. So if we do that, 289 divided by 145 raised to the 1/7 power gives us a growth rate of 1.10, and I'm just going to round that off to 1.104. So the value of that house could be modeled by this function. H of t is equal to 145 times 1.104 to the t power. If we wanted to figure out the value of the house in the year 2020, 2020 is 35 years later. Let me just double check that, because sometimes I don't do my arithmetic well. Yep, 35 years later. Okay, so h of t, the value of the house in the year 2020, would be 145 times 1.104 to the 35th power. 145 times 1.104 to the 35th power, according to my calculator. Oh, let me try that again. Order of operations. Let me try that again one more time. 145 times 1.104 raised to the 35th power is, try that again. 1.104 to the 35th times 145. Oh, nope, that's it. So h of t, if things had continued, that would have predicted the value of the house would be 4626.8 thousand dollars. And if we wanted to change that to a number, 100,000, it would have predicted that the house kept appreciating till it was worth over $4 million. So housing prices did cool off. So that house, no, I'm sure would not sell for $4 million now. But had it continued, that's what it would have predicted.